All right, and now it's time for part two of this little stoichiometry series here. How to solve basic stoichiometry problems. All stoichiometry problems will involve a balanced chemical equation, which I will always give you. And then there's the problem. And here's a very typical one right here. How many moles of oxygen are needed to burn 0.34 moles of propane? In the problem, there's always what we call the given quantity. That's right. The given quantity is an amount of one of the substances that is sort of given to you or specified. In this case, it is 0.34 moles of propane. 0.34 is not 0.34 alone is not sufficient. Okay, that's it's a number, but it's actually an amount. Okay, it's 0.34 moles. It's also an amount of a substance. When solving stoichiometry problems, you're going to be dealing with two substances, so you must always be sure that you match up each number that's in the problem with the appropriate substance. So the given quantity is 0.34 moles of propane. It's a good idea to underline that, and then also maybe underline the substance that refers to it, or its formula in the balanced chemical equation. And then there's always the unknown. Now, what's the unknown in this question? Well, it's the quantity of a substance that you're being asked about. And you are being asked about how many moles of oxygen. Okay, so there's oxygen right there. So we underline with a squiggle the unknown quantity, the number of moles of oxygen is unknown. And I also squiggle underlined that compound from the balanced chemical equation. What about carbon dioxide and water? Should we do anything in this problem with these two substances? No, because they're not mentioned in the problem at all. This problem only involves propane and oxygen. How then can we solve this? Well, I'm about to show you a technique that's called dimensional analysis, which I've shown before, but not too much time. Uh, Truth is, there's probably a dozen ways to answer this question involving ratios or proportions or whatnot. If you find another way to solve these problems and you can solve them all correctly every single time, then go ahead and use that other way. It's fine. However, I'm only going to show this dimensional analysis technique. If you have trouble with dimensional analysis and you cannot find a way to solve them on your own, then let me know and I will make another video showing you another way. I will do that. All right, so how then do we solve this problem? Well, first let's write down the given quantity, and that would be 0.34 moles of propane, C3H8. That's right. I'm going to write it down. Then I'm going to set up some nice parentheses next to it, and these parentheses are going to allow us to do some math. Inside the parentheses, I put a line because what I'm going to create is a fraction or a proportion or a ratio. Notice that I set up the line so that it is kind of underneath the 0.34 moles of propane. The 0.34 moles of propane should be lined up with the top of the fraction, and then this under here should be the bottom. What do we put into this proportion? Well, the propane will go on the bottom. How much propane? Well, let's take that from the balanced chemical equation. The balanced chemical equation says 1 propane, or 1 mole of propane. So I'm going to write 1 propane, C3H8. On the top, we'll put the unknown substance, and the unknown is oxygen, 5 moles of oxygen. So I'll put 5 O2s. Okay? The stuff inside here that I've written in blue came from the balanced chemical equation. The 1 for the propane, bing, right there, and then the 5 for the oxygen, ding, right there. Now we have a mathematical expression which we can solve. And this is where our calculator will come in handy. And so we take the 0.34 and we multiply it by 5 and we divide it by 1 and we hit enter and we get a correct answer. And that correct answer, whoa, hey, there we go. That correct answer is 1.7. Well, 1.7 alone is not sufficient. 1.7 what? Well, 1.7 moles of oxygen. That's what the question asked us to solve for, and that's what we have up on top here, moles of oxygen. So the answer is 1.7 moles of O2, and there you are. That's how you solve this question. Not too bad. All right, let's try another one. Here we go. I gave you a different balanced chemical equation. Doesn't matter. This problem is solved in the same way. First, let's read the question and try to identify the given quantity and the unknown. Okay. How many moles of ammonia? Ammonia? Wait, what the heck is that? This one is ammonia, by the way. How many moles of ammonia are produced by the reaction of 5.15 moles of hydrogen in excess nitrogen? There's a twist here. All right, let's take this one thing at a time. The given quantity is easy to identify because it will have a number with it. 5.15 moles of hydrogen. There we go. That's our given quantity. This is what the calculations are going to begin with. Okay, 5.15 moles of hydrogen. That's this guy right here. What is the unknown? What are we being asked about? We're being asked to find out how many moles of ammonia. All right, so there's our unknown. How many moles of ammonia? That's our, I'll put a question mark here. That helps sometimes. How many moles of ammonia? Now, what's this? Excess nitrogen? What does that mean? Here's what it means to you, long story made short. When one of the substances is described in as excess, that tells you to ignore it. It's there for a reason. There's a good reason to say this, and I'm not going to tell you what that is right now, but we can ignore nitrogen. So nitrogen is not part of how we solve this problem, so I crossed it out. And there we go. We now have a given quantity, 5.15 moles of hydrogen, and an unknown, how many moles of ammonia. Now we can solve. First, write down the given quantity. 5.15 moles of hydrogen, H2. Wait a minute, Mr. Moffat. What happened to that 3? Well, that 3 is a coefficient. It's not part of the formula. So we don't need the 3 here. Do not put the 3 here. That 3 comes in later. Okay? All right. So now we'll set up the parentheses like I did before. Just like so. And I'm going to put hydrogen from the equation on the bottom. 3, there's where that 3 comes in. 3 moles of hydrogen. That's right. That goes right there on the bottom. Whatever substance is here always goes on the bottom. What goes on the top of this equation? Ammonia. Okay, because that's our unknown. The unknown always goes on the top. So this has 2 moles of ammonia. So I'm going to write 2 moles of ammonia. I left out the word moles because it's understood, brevity's sake. Now we have an equation we can solve. Now we can take our calculator and we're going to type in 5.15 first. We're going to multiply by whatever's on the top. We're going to divide by whatever's on the bottom. We're going to hit enter and we're going to get a nice answer, which I'll round to like 2 decimal places because that sounds like fun. And that's going to be 3.43. 3.43 what? Moles of ammonia. All of your answers should be written this way, with the unit of measurement, in this case always moles, but also with the formula. Third problem. And then you'll get a chance to have a go on your own. Here we have a nice reaction between aluminum oxide breaking down into plain old aluminum and breath of fresh air, oxygen. What mass of aluminum oxide, let me start that over. What mass of aluminum will be made by the complete decomposition of 3.79 moles of aluminum oxide? Given quantity always is specified in the problem with an amount. So there we go, 3.75 moles of aluminum oxide. That's our given. What mass of aluminum will be made? Okay, so there's our unknown. The question is asking us, I meant not what mass. This is a typo. Whoops. How many moles? Let me fix that. Woo. Getting a little crazy back there. All right. How many moles of aluminum will be made? Now, what's in between all this? Made by the complete decomposition. All right, well, these words don't really influence the problem, so don't worry about that. All you want to do in doing these problems is identify the given quantity and the unknown or the mystery, okay? And so there we are. Now we can solve in the same way we solved the other ones. Take 3.75 moles of aluminum oxide, write it down. So I'm going to write it down. 3.795 moles of aluminum oxide, Al2O3. Wait a minute, what about that big 2? Once again, that's a coefficient. It's not part of the formula. We're going to use that later. It does not, that big 2 does not need to be written here. Now set up some parentheses. Okay, and instantly let's put aluminum oxide on the bottom. Remember, whatever substance is written here always goes on the bottom. If you always put it on the bottom, you'll do the correct math. And our equation says that there's 2 moles of it. So now I'll put the 2 in there. If you have the big 2 here and here, you're going to get messed up. It only goes here in the parentheses. We're asked about moles of aluminum, so I'm going to put 4 moles of aluminum up on the top, 4Al. There we go. Now we have an equation that we can solve. Okay, now we'll take the 3.795 and we'll put it into the calculator first. And then we'll multiply by whatever's on the top, in this case 4. We'll divide by whatever's on the bottom, in this case it's 2. We'll hit enter and we get an answer. That's a little blurry, sorry about that. 7.59. 7.59 what? Moles of aluminum. Moles of Al. And there you are. That's how you do basic stoichiometry problems. If this was too complicated or tricky or weird and you didn't get it, if you would like to learn another technique, feel free to ask. Like I said before, if you figure out another way to solve these problems and you can get them all correct, then go ahead and do it your way. It's not a problem. Okay? A couple things people misinterpret. The given quantity is always the one with the number. It's not necessarily the second one in the problem. There's no sequence here. Yes, in all the 3 sample problems I did, the given quantity appeared at the end, but it could appear at the beginning. The substance who has an amount of moles described for it is the given. Okay. Secondly, these problems really have no really do not depend on who was a reactant and who was a product. This particular problem involved both two reactants. Okay. This particular problem involved a reactant and a product. This one also involved a reactant and a product. Reactants and products don't really make a difference into how you solve these problems. So don't get mixed up with that. All right, that's it. Give a shot at some of the practice problems and hopefully you do well. And if not, you got to let me know because I can't help you if you don't let me know. That's it. Hand.